Now, we will going to take up the introduction to the projections of straight lines. So, a line, what are all the possibilities in which we can be able to place the line? So, here we are going by the first quadrant. So, why we are going by first quadrant? Because here the object is between the plane and the observer. Suppose if you look from the front view, object is this line is between the plane and the observer. Similarly, when you look from the top view, you can see the object is between the plane and the observer. So that is the reason why we are going for the problems on first quadrant, and all other quadrants we have been neglecting because the university says it is the first projections of point, or the projections will be done in the first angle. So now first we will going to consider a line which is parallel to both HP and VB. How we will going to place a line which is parallel to both HP and VB? So you can see here there is a line which is capital A and capital B. A line is, if you look from the front view, the line is above HP. So the point capital A and both capital B, both are at some distance from the horizontal plane. So the line is above HP. And similarly, when you look from the top view, the point A and B both are at equidistance from the vertical plane. So when you look from the front view, we can see that the point both A and B is above HP by same distance. When it is viewed from the front view, the image will going to fall on the vertical plane. So we can see here A dash B dash is a line which is parallel to HP. When the two endpoints of the line is equidistant from the horizontal plane, then the line is said to be parallel to HP. And when you look from the front view, we can see that the image lies on the vertical plane, which is A dash and B dash. Similarly, when you look from the top view, we can see the distance, the point A and B both are equidistant from the vertical plane. So the point A and B, it is in front of EP by the same distance. So naturally, when you look from the top view, it is projected onto the horizontal plane, where you can see here small a and small b. So these two are at equidistance from the vertical plane. Since it is equidistant from the vertical plane, the line is parallel to VP. So in other words, if I say that if I want to see now, so this line this line A dash and B dash, since it is parallel to HP, so we can see that it is the true length in HP. So you can see that is capital A and capital B. When you look from the top view, it is parallel to VP. Since it is parallel to VP, so we can see the distance. So it will be true length, which will be capital A and capital B in the top view. So the line is parallel to HP. If the line is parallel to HP, then we can see the true length in HP. So that is capital A and capital B. Similarly, in other words, when the front view line is parallel to XY, so this is the XY line. When it is rotated by 90 degrees, we can see that the vertical plane is always fixed. A dash and B dash is above XY line, and AB will going to become below XY line. And when the front view line is parallel to XY, its corresponding top view. So that means if A dash B dash is parallel to this XY line, then its corresponding top view AB will be in true length. So capital A and capital B. Similarly, when the line is parallel to VP, so when you see here, when the two points A and B are at equidistant from the vertical plane, so it is parallel to VP. So then we can see the true length in the vertical plane, which is A dash and B dash. So this is capital A and capital B. So when the line is parallel to VP, so we can see the line is parallel to VP. Its true length is in VP. So you can see that it is true length in the vertical plane. That is capital A and capital B. In other words, when the top view line is parallel to XY, its corresponding front view A dash B dash is in true length. Therefore, we can see here capital A and capital B. So now, this is how we will be able to analyze the problem of line which is parallel to both HP and VP. Now we will go to the next position, wherein the line is inclined to HP and parallel to VP. So if you consider the second position, so now the line is inclined to HP. So you can see capital A and capital B, which is line which is inclined to this horizontal plane, and then which is parallel to VP. So when you look from the top view, the two endpoints of a line A and B both are at equidistance from the vertical plane. So now it is parallel to VP. So when you look from the front view, we can see that the two endpoints of the line A and B are not at equidistant from the vertical plane, not at equidistant from the horizontal plane. Therefore, the line is inclined to HP. When the line is inclined to HP, so here, when it is projected from the front view, you can see that the image will going to fall on the vertical plane. So when you look from the top view, the two endpoints of the line are equidistant from the vertical plane. So line is parallel to VP, and when it is projected, you will going to see that that point will going to be small a and small b. And here, so when the line is parallel to VP, so its true length is seen in the vertical plane. When the line is parallel to VP here, so we can see the true length in the vertical plane. So in other words, when it is rotated, you can see when the line is parallel to XY in the top view, its corresponding front view will be in true length. Similarly, when the line is inclined to HP, so when you are considering the line is inclined to HP, its apparent length is seen in the horizontal plane. You can see that its apparent length is seen in the horizontal plane. So in other words, when the front view line is not parallel to XY, its corresponding top view will not be in true length. Therefore, in the top view, you can see it is not capital A and capital B, whereas you have got small a and small b. So where theta is the true inclination with respect to HP. So this is the capital A and capital B because this top view line is parallel to XY, its corresponding front view will going to be in true length. Now we will go for the next position. The line is perpendicular to HP and parallel to VP. So when you are considering this in the 3 dimension, you can see that the line capital A and capital B is perpendicular to HP and parallel to VP. When you look from the top view, the two endpoints of the line, capital A and capital B, both are at equidistant from the vertical plane. Therefore, it is parallel to VP. Since it is parallel to VP, so you are getting the true length in the vertical plane. So you have capital A and capital B, and it is the front view as A dash and B dash. So when you look from the front view, the capital A and capital B is perpendicular to HP. Since it is perpendicular to HP, you are getting a point in the horizontal plane, which is B and A. But both B and A are coinciding. So when you look from the top view, B is near to the observer, so B is visible, and A is away from the observer, A is in bracket. So when this is rotated by 90 degrees, we can see that the top view, B and A is a point where B is visible and A is invisible. So when you look from the top view, the two endpoints of the line are at equidistant from the horizontal plane. Therefore, you can see the true length in the vertical plane. Therefore, its corresponding front view will be in true length. So you can see A dash and B dash is in true length. So that is why it is denoted by capital A and capital B. So here, since it is perpendicular to HP, so you are getting a point in the horizontal plane. So you are getting the horizontal plane in HP. So point in the HP. When a line is perpendicular to HP, in HP, it will be a point where if you look from the top view, you can see B is near to the observer, A dash is away from the observer, so A dash becomes invisible in the top view, so B is visible and A is invisible. Now we will go for the next position. When the line is inclined to VP and parallel to HP. Now we can consider in 3 dimension. Here, the line is inclined to VP. So since the two endpoints of the line A and B not at equidistant from the vertical plane, so therefore the line is inclined to VP. Since the line is inclined to VP, you are getting the apparent length in VP. Therefore, you are getting a dash, small a dash and small b dash. When you look from the front view, we can see the distance wherein capital A and capital B both are at equidistant from the horizontal plane. Therefore, the line is parallel to HP. Since the line is parallel to HP, so we can see the true length in the horizontal plane. So when this is being rotated, so you will going to get the line inclined to VP in the top view and the line parallel to HP is in the front view. Now we can see that when the front view line is parallel, its corresponding top view will be in true length. Therefore, you will going to get capital A and capital B in the top view, and whereas you have small a and small b, which is also the top view. The two endpoints of the line are not at equidistant from the vertical plane. Therefore, the line is inclined to VP. Since the line is inclined to VP, so you are getting the apparent length in VP. So that is A dash and B dash. Since it is not parallel to VP, so you are not getting this as capital A and capital B. So So the inclination made by the true length with respect to VP is always denoted by phi. So this has been represented here. So when the line in the front view line is parallel, its corresponding top view will be in true length. So we can see capital A and capital B in the top view, and the inclination made by that line with respect to VP is called phi. So true inclination with respect to VP. When the line is inclined to VP, so here when the line is inclined to VP, so you are getting the apparent length in the vertical plane. The line is parallel to HP, so since the front view line is parallel to XY, so its corresponding top view will be in true length. Now we will go for the next position when the line perpendicular to VP and parallel to HP. So you can see here in 3 dimension, the line capital A and capital B is perpendicular to VP. So when you look from the front view, you are getting a point in the vertical plane. Since B is near to the observer, so B dash is visible, and A is away from the observer, A dash becomes invisible. So when HP is rotated by 90 degree, so we can this AB is a perpendicular to XY line in the top view. So here when you look from the front view, the two endpoints of the line, both B and A, are at equidistant from the horizontal plane. Therefore the line is parallel to HP. Since the line is parallel to HP, so you are getting the true length in HP. So we can see here capital A and capital B, and this is small a and small b. So in other words, when you look from the front view, you can see the distance, both B dash and A dash are at equidistant from the horizontal plane. Therefore you are getting the true length in the horizontal plane, which is capital A and capital B. As we see from the top view, as you see from the front view, both B is near to the observer, so B dash is visible, and A is away from the observer, so A dash becomes invisible. So when the line is perpendicular to VP, so in VP you will be going to get a point, so which is B dash A dash in bracket. So this is the representation by using the orthographic projection. Now we will go for the next one more condition. The line is inclined to both HP and VP and parallel to profile plane. So we can see here, this is in the 3-dimensional analysis, wherein the line is inclined to VP, which is phi, and the line is inclined to HP, which is theta. But when you look from the front view, we can see that the two endpoints of the line capital A and capital B are at equidistant from the profile plane. So the line is parallel to profile plane. Since the line is parallel to profile plane, you are getting the true length in the profile plane, that is represented by capital A and capital B. Since you are looking from the left side view, so the image will going to fall on the right profile plane. So A double dash is here and B double dash is here. So when the two endpoints are at equidistant from the profile plane, so we can see it is in the front view, which is at the equidistant, which is both A dash and B dash are at equidistant from the profile plane. Similarly, when you look from the top view, the two endpoints of the line, capital A and capital B, are at equidistant from the profile plane also. So that distance can also be seen in the top view. So when this HP is rotated down and RPP is rotated to the right side, we can see this is the position wherein the two endpoints of the line, both A dash and B dash and A and B, are at equidistant from the profile plane. So now the line is parallel to profile plane. Since the line is parallel to profile plane, so we can see the true length in the profile plane. So we can see here capital A and capital B, and whereas A double dash is here and B double dash is here. Now when you look from the front view, the two endpoints of the line, both A and B, are not equidistant from the horizontal plane. So therefore the line is inclined to HP. Since the line is inclined to HP, in HP you are going to get the apparent length. So you can see AB here. Similarly, when you look from the top view, the two endpoints of the line, both A and B, which are not at equidistant from the vertical plane, so obviously the line is inclined to VP. So you can see that inclination with respect to VP here. And when you project it, so you can see that it is a vertical line of A dash and B dash. So naturally this will also be in apparent length. So when you look from when you take the orthographic projection, the two endpoints of the line of both front and top view are at equidistant from the profile plane. Therefore, in profile plane, you will going to get this line is in true length. So that is A double dash and B double dash. So that is the reason why you are getting capital A and capital B. So you are getting capital A and capital B because the two endpoints of these two lines are at equidistant from the profile plane, that is x1 y1 line. And since the line is inclined to HP here by theta, that is the two endpoints of the line A dash and B dash, not at equidistant from the horizontal plane, so the line is inclined to HP. Since the line is inclined to HP, we can see the apparent length in HP, so we are getting the apparent length in HP. Similarly, when the line is inclined to VP, the two endpoints of the line, both A double dash and B double dash, are not at equidistant from the vertical plane, so the line is inclined to VP, so that inclination is fine. So when you look from the top view, we can see that since this line is inclined to VP, so you are getting the apparent length in the vertical plane, that is A dash and B dash. So therefore, you are going to get capital A and capital B only in the profile plane. But these two lines are not perpendicular to HP and VP, because if it is perpendicular, then if it is perpendicular to VP, then obviously that should be parallel to HP. But here you are getting a line. If you are getting a perpendicular to HP, in HP you should get a point. If it is perpendicular to VP, then in VP you must get a point. But since both you are getting the line in the front view and you are also getting a line in the top view, therefore the line appears to be perpendicular to both HP and VP and parallel to profile plane. So here, when the line is parallel to the profile plane, its true length is seen in the profile plane. In the next position, the line we will consider, the line is inclined to all the three planes. So here, if you are considering this capital A and capital B, the two endpoints of the line capital A and capital B are not at equidistant from the horizontal plane, since the line is inclined to HP, so you are getting the apparent length in HP here. Similarly, when you look from the top view, the two endpoints of the line capital A and capital B are not at equidistant from the vertical plane. Since it is not equidistant from the vertical plane, obviously the line is inclined to VP also. So the line is also inclined to VP. So here, when it is rotated, HP is rotated, we can see here the top view line is also inclined to VP and the front view line is also inclined to HP. Since the inclination is with respect to both HP and VP, so obviously the line is inclined to both the planes. In earlier cases, if the line is inclined to one plane, obviously that line should be parallel to the other plane. But here, the two lines are both the lines are inclined to both HP and VP. So if the line is inclined to HP, so you are getting the apparent length in HP. So you are going to get alpha. If the line is inclined to VP, so you are getting the apparent length in VP. So you are getting the apparent length A dash B dash in VP. So now obviously that angle will be beta. So this is the top view inclination with respect to VP, and this is the front view inclination with respect to HP. So this is the alpha is the apparent inclination with respect to HP, and beta is the apparent inclination with respect to VP. So this is a case wherein the line is inclined to all the three planes. In respect to the profile plane also, both B and A are not equidistant from the profile plane. Therefore, obviously that line should be inclined to profile plane also. So since we are not considering the profile plane, obviously we will not going to be focused from lines onwards. We are not focusing much on the profile plane, but it is not required. But only with respect to if the line is inclined to the two planes, that is the line is inclined to HP and VP. So obviously we will be considering that the line is also inclined to VP. So inclined to the profile plane. So these are all the various positions from where we will be able to analyze the problem in the projections of lines. So in summary, if I want to say the first case is line is parallel to both HP and VP. And in the second case, the line is inclined to HP and parallel to VP. And the line in the third case, line perpendicular to HP and parallel to VP. And the line inclined to VP and parallel to HP. The line perpendicular to VP and parallel to HP. The line inclined to both HP and VP and parallel to profile plane. And in the last, the line is inclined to all the three planes. And the alpha is the apparent inclination with respect to HP, and beta the apparent inclination with respect to VP, and theta true inclination with respect to HP, and phi is the true inclination with respect to VP. So this is how we will be able to summarize all the lines on various positions and various angles with respect to both HP and VP. Thank you.